So I'm going to be looking at our surface development question again, and this time around I'm going to be using the triangulation method to find the true shape of the surfaces. So same question as before. I'm only going to develop surface A and surface B, and we're going to be talking about how we find true lengths and where we're actually going to be referencing them from. So I'll go back to my model space. I've gone ahead here now and I found the true lengths of lines 1 and 5, lines 2 and 6, and lines 8 and 4, because they're the lines I'm going to need to find my true shapes of A and B. And I already have my true length of line 1 and 4, 2 and 1, and 6 and 3, because we see them lines either as a parallel line or as a point view in our elevation, which means it's a true length line in our plan. So I want to get the true length of line 2, 6, for example. What I've done here is I've actually drawn an inverted cone. So the apex of my cone is here at point 2 and the base is up here. So what I've done is I put the point of my compass at 2, rotated 6 back to where it hits a horizontal line projected from 2, which is to represent our vertical plane, and we project that back up and run our line horizontal from point 6, because our heights will never change. Okay, the heights won't change, just the orientation of the line. So the line has gone from being seen at an angle here to being perpendicular to our point of view. So we're perpendicular to this line 2, 6, so now we can see its true length. And we do the same to get our lines here. When it comes to finding a line along the surface of our surface A and surface B, I used a blue line to represent that, and it's the exact same technique to find your points. So if I wanted this line here 1, 6 again, I've done the same. I inverted my cone, so this time I put the apex of my cone on 1, brought it from 6, swung it down to hit a horizontal line representing a vertical plane, brought it up. The heights are never going to change, and I can draw in then my true length from my new point 6 to my point 1. Using these lengths then, so to find the true shape of A, what I done was I started off with just drawing in just any line at any angle, and I started at one end of it and I brought up my true length for my side here, 2, 6. So this first big circle is the radius is the length of 2, 6. Sorry, I actually deleted that circle. The circle I had was radius length of 2, 6, and I marked it off at the center. And then I can take my true lengths from other lines and describe them with their centers and the centers that I found already. And to find point 1, what I can do is take the true length of my line 6, 1, swing it from the top here, from the top line at point 6, and that'll reference that and find that for me. So true shape of A is easy enough to find. B requires a little bit more thinking, because the students have to find 2 lines across the surface to find 2 different points, and that's just because of the 2 separate heights. We can see where I got them points from as well. So I used line 8, 1 to find my corner here, and I used 5, 4 to find my top corner. And this is my true shape, and we use a dotted line to indicate a fold line. That's where the shapes will fold to form the corner. Thank you.